Your job used to take 20 minutes. Today, it's been running for 2 hours, and you have no idea whether it's nearly done or stuck forever. So you do what everybody does. You double the executors, bump the memory, and run it again. Sometimes that works. Often it does nothing, and occasionally it makes the job slower because more executors means more places for data to be sent, more coordination, more network. Throwing hardware at a Spark job is the most common response to slowness and one of the least reliable. Here's the thing that actually works. Slow isn't a diagnosis, it's a symptom, and Spark is unusually good at telling you which one you have, if you look in the right place. That place is the Spark UI, the Stages tab sorted by duration. Almost every slow job in the world is one of 6 problems, and each one leaves a different, recognizable fingerprint there. Find the longest stage, but before you debug anything, rule out the boring answer. Check whether the job is slow because the data grew. A pipeline that was fine at 50 gigabytes and painful at 300 isn't broken, it's outgrown its shape, and no amount of debugging finds a bug that isn't there. Compare the input size to last month's. If it tripled, that's your answer, and the question becomes which of the 6 problems below your extra data just made visible. 1. Nothing is happening at all. You pressed run, and for 30 seconds there are no tasks, no progress, nothing. It looks hung. It usually isn't. Spark doesn't execute your code as you write it. Transformations just build up a plan, and nothing runs until something forces it to. What you're watching is Spark planning, or listing files before it can start.
If that pause is long and your data lives in thousands of small files, the listing itself is the cost. That's a layout problem, not a speed problem. 2. One task is still running and all the others finished. This is the single most common cause of a slow Spark job, and the fingerprint is unmistakable. Open the stage, look at the task duration summary, median 2 seconds, max 11 minutes. One task is doing dramatically more work than its peers. That's skew. You grouped or joined by a key where one value is enormously more common than the rest. One giant merchant, one null placeholder, one default customer ID that half your rows carry. Every other task finished ages ago, and 199 cores are sitting idle, waiting for one. A bar chart of 200 task durations, 199 tiny identical bars, and one enormous bar towering over them, labeled median 2 seconds, max 11 minutes. The first thing to try is adaptive query execution. Modern Spark can detect a skewed join at runtime and split the oversized partition automatically. It's controlled by a named setting, it's on by default in recent versions, and it's worth confirming it's actually enabled before you do anything clever. If AQE doesn't cover your case, the manual fix is salting. Add a random suffix to the hotkey so its rows spread across many tasks, then aggregate twice. Or, if the other side of the join is small enough, broadcast it so the redistribution entirely. 3. The stage has enormous shuffle read and shuffle write numbers. Those 2 columns are the amount of data Spark moved across the network between machines. Some operations can be done by each machine independently on the data it already holds. Others, grouping, joining, sorting, distinct, require rows with the same key to end up on the same machine. So Spark writes everything to disk, sends it over the network, and reads it back. That is the single most expensive thing a Spark job does, and it's usually where your 2 hours went. 2 rows of machine icons with a dense mesh of arrows crossing between them, labeled Shuffle, Write, Send, Read, with a caption, The Expensive Part. You can't remove every shuffle, but you can stop paying for the ones you don't need. Filter before you group rather than after, broadcast the small side of a join, and avoid reshuffling data that's already partitioned the way you need it. 4. There's spill, or the job died with an out-of-memory error.
The Stages tab shows spill columns, and if they're non-zero, tasks ran out of room in memory and started writing intermediate data to local disk. Some spilling is normal and fine. It's Spark degrading gracefully rather than failing. Heavy spilling means your partitions are too big for the memory each task gets. If you're seeing high GC time instead, the executors are spending their effort cleaning up memory rather than computing. And if it's the driver that died, the usual cause isn't Spark at all. You called something that pulls the entire result back to one machine, and one machine couldn't hold. 5. The job reads far more data than it needs. Check how many bytes the scan actually read against how much you use. If your table is CSV or JSON, Spark has no choice. Those formats store data row by row, so reading 4 columns out of 200 means reading all 200. Switch to a columnar format, and the same query reads a small fraction of the bytes because each column is stored separately and the irrelevant ones are never touched. This one change routinely turns minutes into seconds without a single line of code changing. 6. The job rereads or recomputes the same thing over and over. If your query filters by date every single run and your files aren't organized by date, every run scans everything to find the slice it wants. Lay the folders out by the column you filter on, and Spark skips whole directories without opening them. And if the same intermediate result is used by several downstream steps, it's being computed several times unless you cache it. Though caching is a bet, not a free win. Cache something used once, or cache a huge dataset before the filter that shrinks it, and you've spent memory for nothing. So the whole diagnostic in one pass. No tasks running yet, it's planning or listing too many files. One long task, rest finished, skew. Huge shuffle numbers, you're moving data across the network. Spill or OMM, partitions too big for the memory each task has. Reading far more than you use, wrong file format. Same work happening repeatedly, wrong layout or missing cache. And the thing worth noticing about that list, not one of those fixes is a configuration value you can guess. Every one of them comes from understanding what the engine is actually doing with your data, where it decides to move rows between machines, how it splits work into tasks, what it reads off disk before it reads what you asked for. That's what the series this video belongs to is about. 12 episodes, one fraud detection pipeline followed the whole way through. Every one of these problems explained properly rather than as a symptom on a checklist, starting with what a partition actually is and ending with why the fastest Spark job is often the one you didn't need to run at all.